competitors are likely to do. We often treat competitors as sort of a wild card. In strategy, you might think that they're a source of uncertainty, but you can also apply some of this same logic to thinking about how competitors evolve along their trajectories. And what you have to remember is that trajectories of your competitors are being influenced by the environment, just like yours, by customer demands, by regulatory influences, all these exogenous things, but they're also being shaped by internal factors. So for the very same reason, it's easier for you maybe to think about time or to think about cost. It's easier for your competitor to think about particular dimensions they've focused on in the past. Those dimensions they have focused on in the past are likely to be a source of capability for them and also a source of cognitive bias for them. So it's really, really important to think about what your competitor is really good at, not only as their strength, but sometimes as their Achilles heel, because it can help you to predict how they'll view the world, what they'll pursue in the future. And I'm going to give you an example, and it's a nice way of illustrating technology S-curves too. So remember I told you could map out these S-curves if you have some data, and a couple years ago an MBA student and I decided to look at different renewable energies because we thought, well, it's kind of a horse race. It'd be nice to know who we think is going to win, because at the time I think Google had just made a big investment in solar and everybody was talking about wind, and I was just curious, what do the S-curves look like, right? These technologies must have S-curves. I want to see who looks like they're poised to cut off someone else. So we gathered all this data on performance and on investment, and when we applied for the data for the National Renewables Energy Laboratories, they also sent us data on geothermal energy, which I hadn't even heard of at the time. And then we ran the analysis. And then we looked at it, and like, that can't be right. We ran it again, and we ran it a few times. And then finally we had to stand back and go, holy cow, it's such an interesting story. So first of all, this is wind energy, and what you see is you can actually see almost the whole S here, right? Which means that, so there's a couple of takeaways here. First of all, it's almost flattening out here. That technology is almost maturing, right? It's almost, and if you talk to people in wind, they'll tell you, yeah, it's getting harder and harder to get big improvements in wind energy. But another takeaway is that wind is actually really pretty efficient. Like, it's way more efficient than solar. Now this is photovoltaic solar. Holy cow, so much R&D has gone into this technology to get us not very far. Now that doesn't mean it's not a wonderful technology, but if this is, who knows what this S-curve looks like? We don't know yet. Remember when I said earlier in the class today, sometimes it's too early to tell where the inflection points are. That's the story with this technology. It could flatten out here. It could flatten out way up there, right? It could be a series of S's where we flatten out and then we invent a new way to overcome that limit and do another S and do another S. But right now, it's incredibly flat, which means that even though a ton of money is going into it, we're getting very little bang for our buck. And this is a constant scale for all these guys. Right now, wind energy is a lot cheaper per kilowatt hour than solar energy. But all this money went into solar energy. A lot of it went in during the 70s, during the energy crisis. Huge amounts of money get poured into it in Japan because these are all electronics-based companies that started in solar a long time ago. You remember your first little solar Casio watch? These guys made a commitment to solar a very long time ago. So lots of money has gone into solar. This is concentrating solar, which actually matured and is seeing a little blip now. I don't know much about concentrating solar. This is the one that freaked me out, though, because this one I didn't even expect. This is geothermal energy. The first thing you should notice is that it's higher than all of them. So geothermal energy is cheaper per kilowatt hour than all of them. It's also an exponential curve still. So it's increasing. The performance bang for a dollar is really, really high. And we don't know how high it's going to get. And I had thought that geothermal energy was just something that you would get from a geyser, but it turns out the whole planet is covered in what's called hot, dry rock. And so it's just a question of you drill a hole, you pump down a medium that has a relatively low boiling temperature, and it'll create steam or pressure, and then you can get energy from it, and you can get it from all over the planet. And it turned out that MIT had done this big study and shown that there was tremendous energy potential in geothermal, but relatively little development was going on in it. So I looked at this map and I thought, well, that's really funny. Why is it that there's so much potential in this technology, apparent here at least, But there's, and the least was, you know, the one that's paying off the least is down here, but it's getting the most spending. And I started thinking about who invests in these different technologies. Well, this one is a pretty straightforward one. Wind energy. What is a wind turbine? It's a turbine. It goes like this. It generates energy this way, like a dynamo, which is exactly what GE and Siemens were founded on. These are companies, the big turbine companies are companies who have always been in turbines, always been in dynamos, always generated electricity going like that. Mechanical, pretty straightforward technology. So it's no big surprise who the big players are here. When you look at who the players are in solar, it's electronics. And when you ask yourself, why does a company like Google or other companies in Silicon Valley make investments in solar photovoltaics? Well, it makes sense to them, right? It's already part of their supply chain. It's consistent with their capabilities. They haven't really mapped out the bang for the buck compared to other technologies. So they tend to invest in the thing that makes the most sense to them. Electronics, silicon, it fits both their biases and their capabilities, right? So that shouldn't be a big surprise to us. And so then I wondered, well, who would be able to develop this? Who would have the proclivity, the capability, and the tendency to invest out this technology? Well, let's back up and think about what it takes to get geothermal energy. There's land survey, there's drilling, there's extraction, there's awareness of seismic patterns, and there's someone in the room who knows more about all those things than anyone else here. Oil companies. Oil companies were perfectly positioned to pursue geothermal power. But of course, maybe they don't want to. And so then I went to the USPTO database, the Patent and Trademark database, and I pulled all the patents on geothermal power, and sure enough, almost all the patents are held by oil companies. Oil companies know how to do geothermal. They just don't want to yet, right? Because oil is very, very profitable. And around the time we published this article, a guy called me very conspiratorially, a lead guy at Los Alamos National Laboratories. It's a research lab that it's kind of a quasi-government institution. And he called me to tell me that Chevron had bought a great big geothermal facility in California, and everybody was really excited about this, except that all that Chevron did was shut it down. So, yeah. So it's possible that right now, oil doesn't want to let geothermal out of the bag. But this is an interesting way of thinking about how you can think about where your competitors might want to head. Were you going to say something, Joe?
No, this is my field.
This is your...
Yeah, absolutely. So in 2005, I left a hedge fund where I worked on this for the previous 7 years before that. And then I worked on this problem. I worked for the DOE as well.
Oh, really?
I placed this one. But in any event, so yeah, there's a lot going on in my mind right now.
So is the story is this reasonably consistent with the story you guys were coming up with at the DOE?
In 2005, what seems to have changed is the learning curve seems to have been restored for photovoltaics.
So you think this line's accelerating?
Yeah, so if you were to update this, I think you would find it tells an incredible story.
Really?
That's not being reflected here.
Because I heard cheap solar panels out of China would change, or had been changing some of the cost data, but not necessarily the real underlying capabilities story.
Yeah, so the big part of photovoltaic failure is dielectric failure, which is essentially the business of DuPont making an encapsulation material that prevents that kind of thing. It's an expensive bill of material in addition to the silicon. It's up there with the silicon class. They may not be using a reliable encapsulation material and saving money that way. They may be doing it, quite a few other ways as well. And they've more or less eliminated in crystalline silicon, U.S. and Europe from the manufacturing base. So yeah, I think those stories are likely to be true. Another thing here is you're lumping together a wide variety, both thin film and crystalline photovoltaics, and they have extraordinarily different curves.
I mean, creating a single curve for these technologies is tricky because obviously with wind, you have all different height turbines in all different locations. You know, for all of these, you've got some
No,
aggregation
your geo's
problems, I think.
right. I agree with the geo, and I don't think that's changed. I don't think anything's changed for wind work. Concentrating has gotten a little bit tougher because of the work that's, the issue with concentrating is the mechanical that's required. So there's a very small semiconductor that's more or less receiving the energy, and you've got to keep that thing on target all the time. And so that makes concentrating very difficult to achieve. But then again, there's a lot of different types of concentrating technologies out there. But with PV, it's completely changed.
No, this is 10 years old now. We need to update it.
Yeah.
But cool. Maybe you can help me. That would be fun.
Sure. I actually already pulled up a paper that I took out of Germany 2 years ago. That might be helpful.
Oh, wow. Excellent. Is you going to send it to me?
Yeah, I sent you the Goldman. Too.
I saw that.
So
You
if
already
anybody
sent that.
wants
It's
it,
amazing.
yeah, Professor Schilling.
Okay. So we're thinking about competitor trajectories a little bit. This also is a good time to think about Microsoft's decision, again, to get vertically integrated, which was very incongruent with its earlier decision, right? So for 30 years, we thought it was all about modularity. You want to make the thin little piece that you're best at and be compatible with somebody else who's making the other pieces. Right, so we went from mainframes, which are these big integrated systems, and we made mostly by IBM, and we broke them all apart into a system that has lots of different layers provided by all different players. So Intel providing the microprocessors, at one Seagate was providing drives, you have different companies providing memory, different companies providing operating systems, software. So you had all this complete disaggregation of the product and vertical disintegration of the companies for this mix and match modular system, which seemed to make sense. Except that Apple was making better products then, just recently, than anyone else because they didn't have a vertically disintegrated system. They had a vertically integrated system, which gave them more control and also gave them more incentive to invest all along their supply chain. So now for the first time you saw Microsoft saying, okay, we're gonna follow Apple. We're gonna get backward vertically integrated and produce tablets. We're gonna follow Apple some more and get forward vertically integrated. Actually, I've been telling the story in the wrong order, but the first time I was walking in Boston in that, what's that big mall in Boston, Copley Plaza? Have you been there? I was walking, not the first time I'd ever been to Copley Plaza, but the first time since the store opened. I was walking along and I saw the store and I had to just sit down and laugh and take a picture because I had been studying the dynamics between Microsoft and Apple so closely that to see Microsoft open up a store that could not look more like an Apple store was just so incredibly ironic, you know, just really funny. A little unexpected from Microsoft. Okay, so we already talked about why they're integrating into tablet design. Why do you think they're integrating into the store?
Because they're selling the hardware now and you can get the exposure.
And they think they can't, they think that they won't get good enough exposure through the third-party stores?
Yeah, I mean, it's their product. They control the environment in which, you know, the customers interact with it, whether or not they compare it to other products or what have you.
It's a premium product too, so they're competing with a premium product and a premium store and a premium brand.
You're gonna need premium service with your premium
it's kind of hard
products.
to do that if it's being sold at Best Buy.
Yeah, all right, good. What about Google? Why did they buy Motorola Mobility?
Didn't they just sell it, you know?
Okay, but why did they buy it in the first place?
And they thought they could leverage that technology to be into phones.
Yeah. Plus, they needed a patent war chest, right? So that they could make a credible threat against their competitors.
Did they keep the patents when they sold it?
I think they did, but I could double check that. an interesting situation, right? Because one of the problems Google faces with Android is that because they don't have control over the hardware, it fragments the way the software is used, right? You have to produce different versions for different devices, and you lose some of your sort of installed base and compatibility benefits. Do you think this means that Google is likely at some point to decide to produce their own products? Or will they stay with this modular model that Microsoft always had?
I think it's possible they can work their own products.
So what would be the
Never
pros
say
and
never.
cons of that?
Well, they could maximize probably the functionality of their software.
So the pro would be they can make the software more powerful, or more fully deliver on the promise of the software. Any other pros and cons?
Well, if they do that, they could. They didn't do it very well the first time they tried to do it. It doesn't appear as core competency, but they might have had some great learnings there that they could actually go back and say, okay, let's do this differently and learn.
Okay, so
But
they're
then-
not a hardware firm, so they
Right,
might
but
not have
they-
strong capabilities.
But wouldn't they make everybody else that does use their operating system today upset if they entered the market?
So
I'm
they'd be-
serious, why Samsung and everybody else would be like, okay, forget it, we'll go to Microsoft or.
Yeah. So they'd be competing with their buyers, right? Which could alienate them.
Right.
Okay, which has been kind of, a lot of people thought Apple's undoing, having this exclusive. If Google became the only provider of an Android phone, an Android tablet, or Chromebook, if they were the only provider, they might not be able to have the kind of market penetration and economies of scale and scope that they have.
Well, they don't have the distribution channels. Didn't that happen with their phone the first time? The really cheap phone that came out, where there was no storefront, no way to get into consumers' hands, no ways to.
Okay. So, who do you think Google is? What are Google's capabilities, cognitive biases? What do you think Google believes about the world?
I don't think they
could be
know.
known.
They don't know. They're pretty open-minded.
Do know evil, but I don't think that necessarily means anything that they are, right? I mean, you can spend a lot of money on R&D, but not know who you are. You can leverage a good idea, right? But
Okay. So, what we want to do is think about competitor trajectories being shaped by capabilities, what we know how to do, what we're good at, our advantages, our resources, our reputation, our supply chain. Constraints, so things like weaknesses that we have or strategic commitments we've already made. Cognitive biases, beliefs about what works or what customers want, etc. So we want to apply this to Google. On the one hand, we might say, well, they don't really have hardware capabilities, but then again, maybe we can just buy that. Maybe that's not a big problem. They are producing Google Glass, which is a hardware item that would be an interface kind of like a phone would be. So maybe we think they're headed down that path. In terms of weaknesses and strategic commitments, I mean, one constraint they face is that they're really counting on the support of all of these other providers, right? Of all these other hardware providers to build the market, especially abroad, especially in all different price points, which is why we've seen Apple's share shrink so small, has primarily been because they don't have the lower price points, right? Which is very important if you're going to penetrate a global market. Google's made strategic commitments to other players like that would constrain them. So maybe we don't think that they will move down that path. And then finally, there's the cognitive biases, beliefs about what works or what customers want. So Google says their mission is to organize the world's information and make it universally accessible and useful. An information world, right? So their value proposition is about information, which would tend to lead us to believe they would rather focus on the software side, is what I would draw from that, as opposed to the hardware side. Now, we don't know for sure, but all three of these things seem to be pointing to the fact that they're more likely to want to stay on the software side than the hardware side. Does that make sense? All right, now what you want to do is try this with your competitors. Identify one or two major competitors that you really think about, okay? And once you've